A very good morning to you all.
Good morning, teacher.
So last time we had introduced differentiation. Do we have any questions that we landed on? So we saw how differentiation can be done, first principles. And among them, we saw the methods of using delta x. We saw the method of using h. We saw the method of using a small change in x or delta x. We saw the method of power rule of differentiation. So we saw that f of x prime can be got from the limit as delta x tends to 0 using first principles of f of x plus delta x minus f of x, all this divided by delta x. Another one was f of prime of x is equal to the limit as h tends to 0 of f of x plus h minus f of x divided by h. One also saw that dy dx can be got from the power rule. That is, if y is equal to x power n, we saw this as n of x power n minus 1. And also, we could introduce y plus a small change in y, resulting from x plus a small change in x. All these were definitions we talked about, which we can use to differentiate terms. The main three, apart from the power rule, we are being used to differentiate using what we call the first principles. So it is from there that we saw a derivative like this one. One wants to differentiate with respect to x, x power 10. We saw this as the answer being 10x power 9. Then when we differentiated a constant, we saw this as the answer being what? 0. So meaning whenever you differentiate a constant, you get a 0. Whenever you differentiate other terms, you get whatever we have seen. Now, properties of differentiation. Now, whatever we are dealing with is using power rule. We can, for the time being, forget first principles. First principles normally comes when they want to check whether you know how the origin of these functions, differentiation, can be realized. So firstly, if I have y is equal to ax power n, then dy of dx, when I differentiate it, I'll get an of x power n minus 1. That is the first property. The second property, if I have y is equal to ax power n plus or minus b of x power m, then this dy dx will become an, actually it will be like this, the derivative with respect to x of ax power n plus or minus the derivative with respect to x of bx power m. And this will take us to dy dx is equal to an x power n minus 1 plus or minus bm x power m minus 1. So it's the same as differentiating each term alone. Then after you do the algebra, which is either addition or subtraction, depending on the question. The third property, when you have y is equal to x power anything root of a number or a function, then dy of dx will give us a 1 out of n, x power 1 out of n minus 1. This can give us a solution which looks like this one, which is x power 1 minus n over n divided by n when you simplify. The fourth one, when I have y is equal to 1 out of x power n, this is the same as writing x power negative n. So dy of dx will become a negativity of n of x raised to the power negativity of n a minus a 1. So this gives us negative n all is over x power n plus 1. So this makes it a point that whenever the term is a fraction, the power goes on increasing in the denominator. That is if it's a single function. The other one, the other property could be if you have a product, for example, the property if y is equal to a function u in terms of x times a function v in terms of x, then dy dx is going to be, first keep v constant and differentiate u with respect to x, then plus keep u a constant, then differentiate v with respect to x. These ones we shall better understand them when we look at examples of this category. That is, if you can't expand u and v to give us one function, then you can differentiate one, keeping the other one constant, plus differentiate the second one, keeping the first one constant. You'll also check in Backhouse 1 for the derivations of these terms. So this one, you'll check its derivation. I will not derive it, but you can go and read about it in Backhouse 1. Then 6, this is what we call the product rule. Then we have what we call the quotient rule. The quotient rule is when you have y is equal to a function u in terms of x divided by a function v in terms of x. In this sense, dy dx will give us v du dx minus u dv dx divided by v squared. This also is another definition whose derivation you can check in Backhouse 1, but according to what we have now, I'll be in position to identify these terms and we use these properties. So today we are going to discuss how to operate all these properties. Okay. If we don't meet next week, then we might have stopped here today. But if we meet, then I'll introduce at least tangent and normals of curves before we shall close. Okay. So with this knowledge, now we can look at some examples. Okay. So examples. Differentiate the following. Of course, now what is left is around how many examples? We can do around 10 or 15 examples now. Before 10, then at 10 we can introduce tangents and normals so that we can close when you have an idea. So 1, y is equal to 3x power 5. 2, y is equal to 3x squared minus 4x cubed plus 11. 3, y is equal to x power a half minus 4x power negative 3 over 2 plus 1 out of x. 4, 1 out of x, y is equal to 1 out of x squared. 5, y is equal to root of x minus 6x power 1 out of 6. So let me first handle these ones, and the rest shall come on board slowly by slowly. So take a screenshot. So are we ready? Now, with this knowledge of the properties that I've just talked about, We have question 1. Question 1 says y is equal to 3x power 5. 3x power 5. And they want us to use the power rule. Find dy dx. This is the same as saying the derivative with respect to x of 3x power 5. And the answer will be 3 times the power comes forward of x, the power reduces by 1. But I told you from last week, from today on, we should stop writing -1 anymore. So someone should be able to write 15x power 4 hashtag answer straight out. Then come to Roman 2. Roman 2 says 3x squared minus 4x cubed plus 11. In this case, we have seen that where there is addition or subtraction, it's the same as differentiating these terms alone by saying dy dx is equal to the derivative with respect to x of 3x squared minus the derivative with respect to x of 4x cubed plus the derivative with respect to x of 11. Also, this one, we are writing it for the last time. The next time, everyone should just write the answer as 6x minus 12x squared plus 0. So dy dx is actually 6x minus 12x squared. Hashtag solution. Meaning we have differentiated the 2 for the first term to meet the 3, becoming a 6. The 2 has reduced the power by 1, so it became 6x power 1. Then the 4x cubed, the 3 was differentiated by bringing it forward to confirm a 12. Then the x power 3 reduced to 2 by subtraction of the power, giving us 4x power 2. With that, we can go to Roman 3. What does Roman 3 state? Roman 3 is a little bit interesting. It has y is equal to x power a half minus 4x power plus 1 over x. With this, we can differentiate with respect to x. So differentiate this time, you'll get a half, the power comes forward. The x power a half minus 1, you get a negative a half. Are we together? Lutuleila, are you there? Hey, where are the rest?
Yes, teacher.
Yes, are we together?
Yes.
Marcia, is that okay?
Yes.
Monique, are we fine?
Yes, teacher.
Tasneem, are we good? Have you seen how I've got the negative a half? Madina. But this Madina, whenever I ask her, she doesn't answer. Okay, let us go ahead. Minus 4 times negative 3. You confirm a negativity of 12. So it will become a positivity now of 12 out of 2 of x power negative 3 over 2 minus 1. You get a negativity of 5 over 2. So you should be having algebra which can easily make you simplify these items very fast. Now, this one is down. It becomes a negative 1 over x squared. How does that come about? You can go back and check. When we have a fraction, there's a property of a fraction I discussed. Where is it? It is here. If n is equal to 1, you'll have here 1, you will have here negative 1, you will have here negative 1 of x power negative 1 minus 1. So you get negative 1, x power negative 2, same as saying negative 1 out of x squared. That is why I have come up with this answer. Leila, is that clear?
Yes.
Marcy, are we fine?
Yes.
Monica, are we good?
Not really.
Not really. So you're not sure how I've got the negative 1 out of x squared, right?
Yes,
Okay, let's go back to this part. I was saying we are using this definition. You saw this definition? Now, if the definition is like that, assuming our n is 1, so you have y is equal to 1 out of x. This is the same as x power negative 1. When you differentiate negative 1, this is what is expected to happen. You will get y dx, which is y prime, is negative 1, x power negative 2. So this can be written as negative 1 out of x squared, according to this rule I discussed earlier. Madina, you have unmuted. Are you okay? Monica, don't worry, we are coming also to the next number. It is ideally the same as what I was trying to explain. But I hope everyone is okay with this part of the 12. How it became a positive and how it became a 12. So these two can be divided by 12 to confirm a 6. Then our dy dx will confirm our half. Root of x, the x has gone down. A plus 6 of x power negativity of 5 all over 2 a minus 1 out of x to the square. Can I test your algebra? This is hashtag solution. But you never know, the question might say, prove that the derivative is so and so. If they say prove that the derivative is something, you can simplify further by multiplying it by the highest power in the denominator, which is going to be a half of x power negative a half times x to the square plus 6 times x power negativity of 5 over 2 times x to the square minus 1. Now the whole of this one can be divided by x squared as our LCM. Now we are going back to simplifying the first topic we did. There was a topic of algebra we did for simplifying the return of simplification. So whoever was not paying attention to those terms, here they are. So these are indices also. Remember indices, they also came back. Powers and indices. The base is the same, so you add. So 2 plus negative a half, the answer is 3 out of 2. So the first term will be a half x power 3 out of 2. If your head is not good at computing automatically, please press your calculator. You'll be able to get those solutions. Plus 6 of x to the power, same base, cross multiply, you get a negativity over half. Minus 1. All this divided by x squared. I can simplify further. The definition of the topic today is already done. We are just doing earlier topics, simplifying. So dy dx can be x to the power 3 over 2 plus 6 of x power negative a half minus 1, but here there is over 2 and there is over x squared. I can still make the numerator have a common denominator, which becomes x to the power 3 out of 2 plus 12 x to the power negativity of a half minus 2. All this is divided by 2x to the square. Hashtag, this can also be a solution. So they can ask you to prove that. So it is okay. You have only one step. Second step is the answer for differentiation. But if the question comes saying prove, so it means you simplify as far as possible until you arrive where the proof is actually asking you to arrive. Okay? Have people got me right there? That definition of proving as far as what the question would like. Now, the next part was saying y is equal to 1 out of x. That's why I was saying, Monica, come back and look at now this part very well. This is the same as x power negative 2. So dy dx is going to be negative 2 x power negative 2 minus 1. You realize that the answer becomes negativity of 2 out of x power 3. So the power increases, then the power you had before becomes the numerator with it attached a negative. We have seen how it comes about when you go back to its definition. There was a definition of that, which is here. You see what I gave you? That dy dx becomes negativity of n divided by x to the power n plus 1, meaning the denominator power increases, but the numerator becomes a constant resulting from the power you had before, which was down. When taken up, it became a what? Negative. So that is how those fractions can be simplified if they are just single terms like that one. So Monica, are we better now?
Yes, teacher.
Then differentiate for me this one. Monica, give me the answer. Y is equal to 1 over x power 5. When you differentiate that, what answer do you get? By I.
Teacher, what's the question?
1 over x power 5. What do you get?
Negative 5 out of x to the power 6.
Thank you so much. Lutu Leila, are you there? Lutu. Leila. Lutu Leila. Mase, are you there?
Yes.
Hey, Mase, differentiate for me 1 over x power 10. You should be able to do them by I. Just give me the answer.
Negative 10 out of x to power 11.
Correct. Thank you. Monica, are you there? That was Monica before. We had Maria Kankwasi. Maria, are you there? Maria. Swale, welcome. Though you are late. Swale.
Yes, teacher.
Have you understood this part I'm on?
Yes, teacher.
Can you differentiate for me 1 over x power 15? What do you get? Straight away, give me the answer.
Negative 15.
Yes.
Out of x power 16.
Out of x power?
Negative 15 out of x power 16.
16, thank you. Very correct. Okay, lovely that. So we can proceed with the next example. The next example was a mixed fraction with a root. So y was equal to root of x minus 6x power 1 out of 6. They're asking us to find dy dx, that is differentiated. The first term is the same as getting a what? A half of x power negative a half minus 6 times 1 out of 6 times x to the power negative 5 out of 6. So the answer becomes 1 out of 2 root of x minus x power negative 5 out of 6. This already is the answer. This is also an answer. There is also another one. 1 over 2 root of x minus 1 out of x power 5 out of 6. Because it was a negative power, when I take it down, it becomes a positivity. Then one can simplify as much as they can. So that's how far we can go with those questions. Can you give me this answer? This one is for the learners. Activity. Differentiate now. Y is equal to 3x squared plus 7x minus 4 plus 1 out of x. Get me that answer. I expected someone to give me the answer now. You see the answer by looking at the question. You don't need to work out. Don't show us that you are subtracting the power. This is the power rule. Power rule, the next step is the answer. You have already seen how we handle that. So by now, you should be able to handle that off head. Someone with an answer.
I've got 6x minus x out of x squared plus 7.
6x plus what?
Plus 7 minus x out of x squared.
Plus 7 minus x minus what?
Minus x out of x squared.
It is not x out of x squared. Check that last part has a problem. Someone else?
Teacher, I've gotten 6x plus 7.
Yes.
Plus 1 out of x squared.
Plus 1 out of x squared?
Yes.
No, the plus is wrong. Check that sign again. Another one.
Plus 1 out of x squared.
Remember, when you differentiate 1 over x, you get a negative 1 over x squared. So how does your negative turn into positive? Are you getting my point? Shouldn't have gotten a positive there. It should have been a negative. Okay. Okay. Furthermore, more examples. Now, I think the first properties are all covered. The next example is going to be in terms of product rule. For example, 2x plus 3 and x plus 1. This is okay. Very clear. Everyone can expand. So you can first expand, and we use the first method, which is 2x squared plus 3 plus 3x plus 3. Y is equal to 2x squared plus 3x plus something is wrong. This is 2x plus 5x plus 3. After expanding it up to this level, it is ready for differentiation. Therefore, dy of dx will be 4x plus 5, hashtag solution. So there is method 1, you expand the term and get the answer. Now, method 2 is the product rule I talked about earlier. How is the product rule?
So may you work out the other question?
Pardon?
May you work out the other question that you have given us?
What answer have you got?
So may you work it out?
Okay. Dy dx will be differentiate 3x squared, you get? What do you get, Swale?
6x.
Yeah?
6x.
6x. Differentiate 7, what do you get? 7x.
7.
You get 7. Differentiate 4, what do you get?
7.
When you differentiate a constant, what do you get?
0.
0. Differentiate 1 out of x, what do you get?
Negative x.
Negative x.
No.
Girls, what do you
X
get?
negative.
Girls, what do you get when you differentiate 1 out of x?
-1 out of x squared.
Out of x squared. Hence solution. 6x plus 7 minus 1 out of x squared. If you want to be or to show that you're a special mathematician, 6x cubed plus 7x squared minus 1 all is over x squared. Answer. So are you happy now?
Yes, teacher.
Okay. So we are saying we have method 2 now. Method 2, you have to let. You let y be equal to 2x plus 3 of x plus 1 be in the form uv. And you let u be 2x plus 3. You let v be equal to x plus 1. You need to get du dx, which is 2. You need to get dv dx, which is 1. Then go back to the definition of the product rule. duv dx we saw as keep v constant, differentiate u. Plus keep u constant, now differentiate what? V. Those people who cram very well, they always say differentiate one, keep the second one constant. Plus differentiate the second one, keep the first one constant. Or differentiate one, keep the other constant. Then after, add on the differential of the second term, which you didn't differentiate in the beginning. Time was the term which in the beginning was differentiated. So this is what the idea is. But don't worry, these formulas are always given in the logbook, if you're to use the logbook. And most so, if you practice a lot, they will stick to your heads. And with the time, in pure math, we don't write the formula. So you don't need to write the formula. You just need to work out. So therefore, what does this mean? It means the derivative of y with respect to x is going to be, what is our v? X plus 1. What is our du dx? 2. Plus, what is our u? 2x plus 3. What is our dv? 1. The answer becomes 2x plus 2 plus 2x plus 3. Final answer becomes 5. 5 plus 4x. Hashtag solution, which is the same as that one. With this, you are using what we call a product. I think I can give an example. Now, there are sometimes questions which will come whereby they are not easily expandable like this first one. Yeah? Well, no, one may wonder, but now why is teacher giving us the product rule? Yes, the other one is cheap. Questions are going to come like this. Example 2. Y is equal to root of x times 2x plus 1. See that? Then one can say, I let my u be root of x, so that the u dx is a half of x power negative a half. Then my v to be 2x plus 1, so that my dv of dx becomes 2. Because of our formula we have attained already, we can substitute. And substitute and have dy of dx being equal to v du dx plus u dv dx. So v is what? 2x plus 1. Du dx is a half of x power negative a half plus u, which is root of x, times dv dx, which is 2. You realize that you have 2x plus 1 out of 2 root of x plus 2 root of x. Indices and powers. Simplify further, you will realize 2x plus 1 plus 2x out of 2 root of x. This will give us 4x plus 1 times, or out of 2 root of x, hashtag solution. But even this one here was already a solution. If they tell you to simplify as far as possible, you can go as far as down there. There's another property I need not state. Let me see if I can state it. Yeah. Property 7. Let me state it here where I am. There's a property I wanted to state, property 7. When you're given y is equal to ax plus b power n, then dy dx will be, first differentiate the power, you get n into ax plus b power n minus 1, then times the product of the derivative inside the bracket. So that technique or that property states that dy dx will be na brackets ax plus b power n minus 1. And I'm going to show you examples that also concern this one, because I've seen some of these ones can be mixed with product rule. This is example. If you're given y is equal to 3x plus 4 raised to the power 20. You know you're used to power 2, power 3, you can easily expand. Now, here is a question, it has power 20. You cannot expand up to power 20. So what do? We use this property to differentiate such a function. Okay, now check this out. This is going to become dy of dx. First differentiate the power, 20 comes forward. 3x plus 4, 20 reduced by 1, you get what? 19. Times the derivative of the term inside, which is 3x. So the answer becomes 60 of 3x plus 4 power 19. Let me give you another illustration on that. Y is equal to root of 2x squared plus 3x. Do you see that this is the same as y is equal to 2x squared plus 3x with the powers a half? When you're differentiating this function, you'll first differentiate the power to a half over 2x squared plus 3x. Reduce the power a half by negative a half times the term inside differentiated, you get 4x plus 3. They multiply each other, and that is the answer. Swale, are we fine?
No.
No, you're not saying anything. Please, you have to ask. This is advanced level math. Any challenge you get, raise it before the teacher proceeds. So, Swale, where is the concern?
So the other example where you got put 2 square root of x.
This one, huh?
Yeah, how you got 2x plus 1 divided by 2 square root of x.
Hey, how I got this one?
Yes.
Do you know how I got this one?
Yes,
Well,
teacher.
this was the v, not so?
Yes.
Du dx was what? This is du dx, substitution.
Yes. Yes.
Now this power negative a half, I take it down
yes.
to meet the 2. It became a positive root of x, or x power half. Has it made sense now?
Yes. Yes, teacher.
How about this? Now, this rule, I sometimes call it PTA. We call it PTA because it is applicable to trig functions when differentiating trig functions. That's why I stopped dealing with trig, because I was about to reach PT, trig functions, differentiation. So that rule can call it PTA. It means power, trig function, angle. But if you're differentiating a bracket, it means a power, then bracket. What is inside the bracket? power of the bracket and what is inside the bracket. So the PBI is a little bit complicated, so we normally have it as PTA. Okay, so I want to give you one more example of this category, then you try out one also. Lutula, your hand is up.
Bishop, we have not understood that last exam very well.
Last example. You agree that the power is a half?
Yes.
Let the power a half sit here. You agree? Then a half minus 1, you get negative a half. Lutu, do you still agree with that?
I don't.
Because a half is sitting here, subtract of 1.
Yes.
You agree?
Yes.
That is the derivative of the power on the bracket, because we first differentiate the power. Then after differentiate the term inside, Lutu, differentiate for me the inside term. You have 2x squared plus 3. Differentiate, what answer do you get? By eye, just look at it and give me the answer. Lutu, when you differentiate 2x squared, what do you get? Leila,
4x.
you get?
4x.
Which is this one. When you differentiate 3x, what do you get?
You get 3.
Which is this one. So this is the derivative of the inside term. Then you multiply it by the derivative which arises as a result of the power being differentiated. The answer you get is the solution. Let me give you another example. Another example, ideally the same idea can look like this. Y is equal to square root of 4x power 6 minus 5x to the cube plus 11x. You see the whole of that function inside the bracket, inside the root. Looks funny. So dy dx will give us, first differentiate the power. The power is a half. Root 2, what does the power become now when you differentiate it? What power will I have here, root 2? A half minus 1, what do you get? Leila, this was the same as 4x power 6 minus 5x to the cube plus 11x raised to the power a half. Now I'm differentiating this power a half, it has come forward. What power will remain here after subtraction by 1? Leila? Eh? Negative a half. Then differentiate what is inside. What is inside? We shall get 24x to the power 5 minus 15x to the square plus 11. And this would be our answer. You stop there. Y is equal to 6x power 4 minus 11x power 7. All this raised to power 100. You can't expand that. So you use PTA and say dy of dx is going to be 100 6x power 4 minus 11x to the 7 to the power 99 times the derivative of the term inside. You get 24x to the cube minus 77x to the power 6. And that is our answer. This is PTA. Another definition that I've not talked about. Okay. Any other person with a question? No person with a question. I want to try out for me one. Actually, trying out for me two numbers. Activity. Y is equal to 6x power 4 minus 3x squared, all this raised to power 25. The second one is y is equal to root of 6x squared minus 6x cubed minus 11. Try those two numbers before I can merge PTA with product rule.
So the dot means multiplication.
Yeah, the dot means multiplication. So you multiply after differentiating the power and multiply by the term differentiated inside the bracket. Answers?
So I've got
Which one?
the first one. I've got dy over dx is equal to 25 into 6x power 4 minus 3x power 2 brackets power 24 times 20 in brackets 24x power cubed minus 6x.
Correct. Now, sometimes some people go ahead and simplify it as far as this. And they say dy of dx is equal to 25 brackets 6x to the fourth minus 3x to the square brackets to the power 24 times 24x to the cube minus 6x. Now they factor out the 6 here and you realize 25 times 6 brackets 6x to the fourth minus 3x to the square power 24 times open brackets 4x to the cube minus x. Others even can go as far as factorizing out the x from these two. Then 6 times 25, what answer do you get? That is 150. So you can end up getting 150x brackets 4x squared minus 1 times 6x to the fourth minus 3x to the square power 24. This is an answer, this is an answer, this is an answer. All of them are correct. The reason why I show you sometimes these further simplifications, the question may say, show that the derivative is given by that one. Yes, please.
So you factorized out 6, but you left it in the second bracket, in the second line.
You can't factorize out 6 here when it is power 24. You can't. You factorize out only this one, which is power 1. We only factorize those terms which are raised to power 1. You can't factorize it when it is power 24. The power 24 is already factorized. Yep.
Yes.
Someone give me the second answer.
A half into 6x to power 3 minus 11 into negative, into power negative a half times 18 squared.
Times 18x squared. This one you can simplify and get the answer as 9x squared brackets 6x cubed minus 11 to the power negativity over half. Correct answer. Also, one can say this is 9x to the square, or is over 6x to the cube minus 11 under the square root. Correct answer. Who got the second one? None. But you can simplify as far as possible, okay?
So 9x from where?
9x from where? The half has divided by 18. Yeah?
Okay, sir.
So can I mix them now? Hope now you know PTA. You have already seen product rule. Now they can give you a number like this one. Y is equal to root of x minus 1 times root of 2x plus 1. Now you let u be x minus 1, already this is power a half, times, and v to be 2x plus 1, also this power a half. So this will give me du dx is equal to a half of x minus 1 power negativity over half. Then dv dx is going to be a half of 2x plus 1 power negativity over half times 2. Here I had not considered the multiplication because it is a silent one. Because when you differentiate x, you get 1. Here when you differentiate 2x, you get 2. The definition for product rule states dy dx is v du dx minus u dv dx. Now, when the numbers come in this form, bring out all your energy of powers and indices and the simplifications we did in algebra 1, because we require them now. when finalizing or when factorizing to get the final solutions. So when you substitute, you'll get what is our V? 2x plus 1 power a half. So whoever was wondering where we shall apply them, here they are. Du dx is a half of x minus 1 power negative a half minus u x plus x minus 1 power a half. Those who missed those lessons, you should visit my YouTube channel. That's why I put that channel for you guys. To always go and recap what you've missed. The VDX is a half, brackets, 2x plus 1 power negative a half times 2. I could have lost this one already. For easy simplifying. Yes, this is a plus, not a minus. So by this, you can now have, you factorize out the smaller terms. This is a small term, this is a small term. So the smaller terms are x minus 1 power negative a half times 2x plus 1 power negative a half. When you factorize out the smaller term, this one has gone out. If this term has gone with a negative, the term here remains with 2x plus 1 power positive 1, but it is over 2. Whereby if this one is to come back, it will go back to this one. Then plus x minus 1 also power 1. The 2 on this term was reduced. So this one, if it is to multiply with this part, it will go back to this one. So I can finalize the solution and say, this is going to be x minus 1 power negative a half times 2x plus 1 power negativity over half into brackets 2x plus 1 plus 2x minus 2 all divided by 2. So finally the answer becomes a half, open brackets, of 4x a minus 1, close brackets, open brackets, of x minus 1 power negativity over half of 2x plus 1 power negativity over half. These two, if you are good at simplifying, you can take them down to become positives, but stopping here is okay. So what I wanted out of this is that such examples are going to be showing up over and over, but one should be mindful that if they show up like that, your simplification techniques, factorization techniques of powers of fractions are needed very urgently. So you can simplify the function like that. Okay. So take the screenshot, please. You go over it again slowly. I want to do some 2 examples on quotient rule, then we finalize. So have that unless someone has a question. So as we finalize, let's look at these other 2 examples. One, y is equal to maybe x squared plus 1 out of 3x plus 2. The other one is y is equal to root of x squared plus 1 divided by root of 2x minus 1. Some people can handle this one in this form. And they say this is the same as 2x minus 1 power negative a half. Then they use product rule. You investigate that in your free time because time is up. I only have around 8 minutes. And I've amosh this place. So to start with, this is quotient rule. The quotient calls for the fractions, whereby quotient rule says that if you have du over v differentiated with respect to x, you will get u v, sorry, you'll get v du dx minus u dv dx. All this is divided by v squared. That is the quotient formula. Now we have to let question 1. You let u be the numerator, which is x squared plus 1, v to be the denominator, 3x plus 2. Always what comes first is u, the second one is v. Then get du dx, which is equal to 2x. Get dv dx, which is going to be differentiate this, you get 3. Now we are ready to substitute. This is what is going to happen. Dy dx will now become, our v is 3x plus 2, close brackets. Our du dx is 2x. A minus, our u is x squared plus 1. Our dv is actually 3. Then divide by the v, which was the denominator. But this time round, the whole of it is squared. Then the rest is algebra. You simplify. And you realize 6x squared plus 4x minus 3x squared minus 3 divided by 3x plus 2 squared. This will give me 3x squared plus 4x minus 3 divided by 3x plus 2 raised to the square, hashtag solution. We have questions on that first example. Any questions before I come into the last example?
Yes, teacher.
Yes, please go ahead.
Teacher, is that first part the same as this one, or it's a different number?
Is the first what?
Yeah, where you said y is equals to x squared plus 1. That one, is it the same number?
Yeah, it's the
This
number
one.
I was doing.
Why did you square root it?
Why did I?
Square root the upper part.
Why
Okay,
did I?
all of them.
Why did I square this one?
No. Like
This is another number I'm going to do.
Oh, okay, yeah.
It's the second number I'm going for. So pay attention, guys, for the last number, because this place is going to be clean. I need to summarize very soon. So question 2, y is equal to root of x squared plus 1 over root of 2x minus 1. We let this be u, then we let this one be v. So you let u be root of x squared plus 1. Then v be equal to root of 2x minus 1. Right? Now, remember this can be differentiated using power rule, PTA. So du dx is a half of x squared plus 1 power negative a half times 2x. Then this second term, dv dx, is actually a half. No. Yeah, this is going to be 2x. This is 2x minus 1 power negative a half times the derivative of the inside term, which is 2. Now you have the dv dx, you have the du dx. What does the definition say for fractions? Dy dx is v du dx minus u dv dx divided by v squared. You realize that you know v is root of 2x minus 1. Then du dx, you have seen, I can lose these two actually. This is actually now x into brackets, x squared plus 1 power negative a half minus U is x squared plus 1 power a half times, this 2 can also be lost with this 2. I remain with 2x minus 1 power negative a half. And all this is divided by v squared. V is root of 2x minus 1, but the whole of it has been squared. With the time when you practice, you don't need to write that statement. You just write only the inside term. So the inside term becomes what? 2x minus 1 after squaring. Then the numerator, look at it carefully. You have 2x minus 1 power a half times x squared plus 1 power negative a half minus x squared plus 1 power a half times 2x minus 1 power negative a half. Factorization of smaller terms, these ones and these ones have to go out. When they go out, you remain with x squared plus 1 power negative a half times 2x minus 1 power negative a half into brackets 2x minus 1 power 1 times the x has not been affected minus x squared plus 1 close brackets, all divided by 2x minus 1. So you simplify this term by opening brackets. You can see that you realize if these two go down, we shall have x squared plus 1 power a half times 2x minus 1 power 3 over 2. The numerator becomes 2x squared minus x squared plus minus 1. Then you finalize and get the numerator as x squared minus x minus 1 out of this denominator we have attained. And that is our answer. So they require patience when they come to that stage. A lot of algebra is needed and simplification. But otherwise, the definition was already handled here and there. Okay, so my time is up, unless if someone has a very quick question, which I can wind up with. Otherwise, if we don't have a very quick question, I would like to beg and stop here. And in case you land on any other, please someone visit Workhouse 1 and send us numbers so that we take a look at them. Any challenging numbers, you can always inbox me and I see how to help you on differentiation. Okay. So with that, take the screenshot, please. Okay, hope you're done. Have a wonderful day.